Hello everyone, my name is Jun Tae-jun. I'm from Artificial Intelligence Conference in Chennai National University. Today I would like to introduce about my research, stress analysis with dimension of valence and arousal in the world. Stress is no more prominent that is characterized by a feeling of emotional or physical tension. Existing research has conducted experiments on data collected from controlled environments with limited stressor. Recognition of multiple levels of stress is challenged due to the lack of easily accessible data with real-world context. In our research, we introduced a dataset from movies with 1,236 video clips. Each video clip is evaluates multiple levels of stress, valence, and arousal based on facial features. Analyzing the relationship between stress and continuous dimension of valence and arousal. Developing a baseline model based on deep learning techniques for stress level detection. The previous datasets collected data in controlled laboratory conditions with limited context and stressor, such as time pressure and interruption. Emotion elicitation clips implies stress has many different levels and is variably expressed in each particular case. This is some experimental setup in a dataset. Our dataset focused on stress detection based on facial expression. Data were collected from 41 different Korean movies. One video clip focused on visible face composed of facial expression. The stress values also were evaluated with multi-levels. The collected data has diverse phases in various situations under the impact of many different factors. In this table compare between our dataset with other datasets we have introduced in previous slide. In our dataset, we annotated for three classes: stress, valence, and arousal with value range of 1 to 9 for each class. 1 to 9 corresponding to non-stress to stress in stress, and negative to positive in valence, and inactive to active in arousal. This is some example we annotated in our dataset. Our datasets were annotated by 27 college students with age range of 21 to 26. We have some requirements for annotator as no history of mental or psychiatric elements, no be under medication even for simple illnesses such as the common cold, because health and mental issue can affect the emotional perception of the character in the video. We also guide them that they were instructed to immediately and quickly change the facial expression for emotion label as they feared and were taught to avoid making a conscious effort to respond. They were also prohibited from any discussion with others to avoid any bias or influence. Annotating the value of class for each video. On video clip is annotated by 27 annotators. The annotators should label one value in the rank of 1 to 9 for each class, stress, balance, and arousal. This is the distribution of three classes, the number of video clip and this value, stress, and valence, and arousal. We also compute Pearson correlation coefficient (PCC) between stress with two dimensions of valence and arousal. This is the value of them, and we observe that the PCC value between stress and valence is negative value minus 0.96, which negatively correlates. This means that when the value of stress increases, the value of valence tends to decrease. Vice versa. Conversely, the PCC value between stress and arousal is positive 0.78, which positive correlates. This means that when the value of stress increases, the value of arousal tends to increase. When the value of stress decreases, the value of arousal also tends to decrease. This is our baseline model. From video frames, we use Tinify model to attract face. Then we use redness 15 to attract feature from face. After that, we use LSTM and full connected layers to change and predict value of stress, balance, and arousal. And this is the network parameter we use in our baseline model. For this is baseline model performance on Dataset in terms of LMSE, MRE, and PCC we get from our model. Conclusion. Our dataset contains video clips close to the actual scheme to address the problem of stress recognition integral for this task. The video clips were evaluated and annotated with a 9-level scale for stress, balance, and arousal classes, developing a baseline model based on deep learning techniques to verify that the level of stress, balance, and arousal could be assessed in our dataset. Stress has a positive regulation with arousal, and a negative with balance. Thank you for listening.